Right? Why is that problematic for carbonate? I didn't give you the formula. You would have had to have it memorized. You mean off of the list of polyatomic ions that I said you needed to memorize? Where we have carbonate ion and we have the little star next to it, and I said you needed to memorize that? Yeah, that's exactly what I mean. You needed that context to be able to answer this question. Okay? So, our formula, let's see. We'll get more and more space as we solve. CO3 minus 2. So total the valence electrons for each. Okay? So, and count charges. So if we now erase our step, carbon has, I heard someone say it, 4. How do we figure out 4 valence? The column above it is 14. Minus 10 gets us our 4. If you don't like the minus 10, look at your periodic table that I gave you on the exam. What does it say above carbon? It actually says blatantly 4. There's no interpretation. It actually says 4. There's not even Roman numerals. Okay, oxygen. How many electrons? 6. Okay, but there's 3 of them. So I get 4 plus 18. Plus 2. Why are you saying plus 2? We have a charge. Charge is referencing the balance of protons and electrons. The charge is always specified in the upper right-hand corner. It is a minus 2. How do I become negative?
Add electrons.
I had to add electrons. To become a negative 2, I had to add 2 electrons. Which means my total is 24. Choose a central atom to act as a connector or bridge. The connector or bridge is usually the least electronegative. Oxygen, being close to fluorine, the most electronegative, is more electronegative than carbon, which means carbon's our center atom. So let's draw it over here. I will then scatter the oxygens around it. Right? I'll now add electrons in pairs to the most electronegative atom first. Let's go ahead and show those as purple. Oxygen, being more electronegative, gets the electrons first. I've now drawn 8 electrons. 10, 12, 14, 16. That would be 18, 20, 22, 24. Yeah? Okay. Continue adding electrons to the rest until our total electrons are actually accounted for. We also did that in purple, so all that's done. Convert pairs of electrons between atoms into a line. Okay. I noticed a couple people doing this. Is this pair of electrons between atoms? No. So don't turn it into a line. Okay. You didn't lose points for that. Whoops. Okay. But if you did, that's understandable. That's from some old school chemists. Okay. Completely useless. Don't do that. Okay. So let's leave that as a pair of dots. How about the next pair of electrons?
Yes.
Yep. Ooh, that worked. Let's convert that into a line. We'll call that blue. Okay, do we have other pairs? Yep. Make those blue. For those of you at home writing this out, you mean I have to bust out an eraser? Yes, this is one of the times where pencil becomes useful. Use an eraser, erase your work. Or draw a new structure. I don't care. Either's fine. Okay? And now we move to rule 6. And this one's the doozy. We will move non-bonding pairs of electrons between atoms that have not satisfied their octet. That means we have to go through every single atom and decide how many electrons are around it. How many electrons are around the rightmost oxygen? There's 2. That would be 4, 6. That line represented 2 electrons. That's 8. So there's 8 electrons around that oxygen. How about the next oxygen? They all got 8. Good call. Okay, so, I'm done then. I can move on. No, we still have carbon. How many electrons around carbon? 6. We don't have an octet. So I have to move a non-bonding pair of electrons between the atoms that have not satisfied their octet. Right? And as we talked about this in class, a common misconception is say, oh, well, I'll just move the pair of electrons there. That's not, number one, that's not what the directions say. The directions say between the atoms. I moved the pair of electrons from oxygen to carbon. That's not between, that's from atom to atom. It says between. So if I move them between, I now have a pair of electrons between atoms, and that can be converted into a line.
A double bond.
Which or where did I have pairs of electrons to move? On the oxygen. Which oxygen? All of them. Which means? Resonance. You have to draw it 3 times where you've shown the double bond in each of those locations. That is not this structure. Because that structure, what's the issue with carbon?
Too many atoms.
It's now exceeded its octet. It has more electrons than it's allowed to hold. What you are attempting to do is draw a hybrid structure, okay? Which I honestly don't even know if the textbook talks about hybrid structures. Okay? Shows up in OChem, and ultimately they're horrible depictions. Okay? If you took a picture of an action shot, okay, something moving around, right, it gets blurry. Okay? Would you be able to tell who it was if they were moving? No. So you'd probably look at that picture and say, that picture sucks, and you throw it away. Okay? It's showing the action, but you've lost the knowledge of who that person is, so it's gone. And you keep taking pictures until you get that picture where you can see the person. You've lost the action ability of it, but you now have the information. This is the information of who that person is. We aren't concerned about the action. Okay? We want the individual freeze frames. Which means for that question we had to draw 3 structures. Okay? And because I was feeling generous, well, not really feeling generous, it's just the way I graded it. Okay? As long as you drew one correctly with the dots, as long as you showed me that there were other structures for resonance, even ignoring the dots, I was okay with it. Okay, why? Time. Okay? You've acknowledged that resonance was valid, and that was it. Okay? Make sense? Follow the rules. Okay? Which is fun because I was about to skip and move on, and I myself did not follow the rules. I followed every rule up to 6, didn't I?
Assign all nonsense.
Oh, 7. Assign all formal charges in the upper right-hand corner. -2. I put the brackets around it. Okay? I could just as easily, because I noticed a couple people did this, do the bracket shorthand and saying -2. Both of those were acceptable. I might have even circled it and said lazy. I taught you that, so it's fair. Okay? Make sense? Follow the rules. If you go through and do the next one, which is which ion? Bromate. Okay? That's a harder one. I didn't expect you to have that one memorized. The bromate ion, you'll notice, does not have resonance. Okay? Because rule 6 does not need resonance. The reason we have multiple bonds is rule 6, not because some activity says draw a double bond. Okay? That's stupid. Okay? And you can take that to the bank. You can take that to the rest of the faculty and have them be like, Mike said you're stupid for saying draw a double bond. Yep. Told them to their face. It is stupid to put that in an assignment. It removes the understanding of Lewis structure. Lewis structure comes from the balance of electrons. Okay? So, polyatomic ion naming showed up a couple times. You need to have some of those memorized. We already had one right at the very beginning. Converting units is a process. Okay? What does our process start with?
The answer.
Okay? Sort of the answer. What do we want? We want the units on our answer. Okay? Then what's our next step? What units were given? Okay? So the book goes through and says units given. And then what do we go through and do? We set up conversion factors, however many we need, to make the units given equal the units for our answer. Right? That's the process. Each of those sections is an individual value, okay, or a conversion system. They aren't blends. Okay? If I tell you 100 and, I think it was 96, what was the kilometers per hour? 105. 105 kilometers per hour. Okay? I got a lot of people writing 105 kilometers per 60 minutes. Okay. It's not wrong, but are they the same thing? No. What you are doing is internalizing a conversion. The instant you internalize it, all things go to hell. Okay? The path to hell is paved with your brain. Okay? Path to heaven is paved with your writing. I don't know. Close enough.
This needs to be a new version of Dante's Inferno.
Okay? So let's take a look at the question, because we've all got it. B. What answer did we want? Minutes. Okay? Not miles per minute. Okay? A few of you may notice that there's a little scroll that looks something like miles squared per minute. You might be wondering what that statement is. What that statement is looking at your work saying, this is what your work is getting for a final answer. Miles squared per minute.
We only want minutes.
We only want minutes. Not only that, where do we want minutes? In the numerator. Where's your answer showing minutes show up? In the denominator. You used one of your conversion factors and put it in the wrong spot. Okay? In and of itself, that's not a big issue. That is easily fixable. Okay? But you at least have to track your units so that you can see you made a mistake. Okay? So what else were we given? We had 105 kilometers per hour and we had
90 miles.
90 miles. Okay? This is where I think potentially something went sideways. How many of you are lazy? Honesty is the best policy. How many of you are lazy? That's not much better. So the rest of you are just that lazy, you're not even going to raise your hand. Okay.
People sleeping.
What is your abbreviation for miles?
MI.
What was your abbreviation for minutes?
MIN.
I think that's what happened. What now goes wrong?
You're in the wrong conversion.
You're trying to solve for the wrong system and everything is haywire. If you're going to be lazy, that's fine. Make sure you're not losing information in your conversion. Okay? One of our first steps when we're trying to go through and convert is to write down what we started with. Okay, well, what did we start with? I was given two things. Okay? So it can be challenging to figure this out. Okay? I had a couple people write 90 miles. I was starting with 90 miles. Okay? Believe it or not, that wasn't a bad place to start, so let's get rid of that. A couple people we started with 105 kilometers per hour, so I'm going to start with that. Right? Mike said I can start with whatever I want. Yes, I did, with one big caveat. Minutes is a measure of where do I want my units of time to be? In the top, or the numerator. 105 kilometers per hour. Where's my unit of time? In the denominator. Did you place your starting things correctly? No. So let's track this, because this is what several people did. Okay? I would say probably the majority of people got it wrong, did this. So let's move through. Okay? I know I want hours to become minutes. And actually, let's switch that up, because I think the way most people solved this was getting rid of the kilometers. They said they wanted to get rid of kilometers and wanted to get into miles. So how do we do that?
1 mile is 1.6.
1 mile is 1.61. Everybody found that. That was on the front of the exam. So cool. We've gotten rid of kilometers, and we now have miles per hour. Okay? And this is where things went sideways.
It's always going sideways.
90 miles. And you said, well, hours, 60 minutes. Because I want to convert to minutes. So we take a look, our hours convert. Awesome, this is fantastic. I'm getting minutes. What's my unit? Am I getting miles per minute? The miles don't cancel. They're both in the numerator. The unit we get out of this is miles squared per minute. Okay? That's a bit of an issue. Okay? This is why you have to track your units appropriately. Okay? You thought, well, 90 miles, that was given information, so I should put that in. Yes, you should put that in the correct location, not just always in the numerator. I want my miles to cancel. And so when we talked about this conversion, if I want miles to cancel, where does miles need to show up in that conversion? In the denominator. Am I given miles? Yes, I'm given 90 miles. 1. I don't want to do 1 over 90 miles. I don't care what you want. That's what it says. Do what it says. What happens? 1 what? Exactly. That's an interesting question. 1 what? I'm given 90 miles. There's my 90 miles. 1 what? Nothing. There is no unit there. If I put in any unit, it's not 90 miles anymore. If I put in a number other than 1, it's not 90 anymore. Okay? I have to keep the measure or that measurement as valid. If I put in anything above that, that is no longer what was given information. I'm doing an interpretation. You may do that interpretation right. That's a separate issue. But the interpretation or the data given is just 90 miles. Okay? And you might be saying, well, I want to put something up there. What are we saying to do by putting the 90 miles in the denominator? Divide by 90 miles. That's it. Okay? I don't want anything in the numerator because I'm not doing anything else with 90 miles. That's the only information I've got.
Seems arbitrary.
Which seems arbitrary. And yes, we have to dig into this.
Everything has a unit associated with it.
Yes.
And now we can just put something there that arbitrarily has no unit.
Yep.
So the rules apply until they don't apply.
Okay. Let's crank through this calculation because this is ultimately going to get us the wrong thing, and we'll switch it up to the correct version, and we'll have that same argument. Okay. So let's hold that thought for the moment. You're saying it's arbitrary. There is no unit associated with it. That can't be fair. Okay. Miles cancels. What unit would we have?
Hours. Nothing.
Would we have hours?
We've canceled all our units.
Okay. There was a line through hours. Was there anything canceling hours in the work shown? No. So I did not cancel hours. What unit would I have?
1.
1 minute over hour.
1 over hours. Where are the hours located?
Bottom.
In the bottom, the denominator. I can't just say hours now become on top. They don't. That unit is in the denominator. It stays in the denominator. Okay? Until I move it out of it. Okay? Which becomes an interesting dilemma if we try to continue through with this. I want hours to become minutes. Okay? Can I convert hours in minutes? Yes. What is that conversion? 1 hour is 60 minutes. Okay? Hours cancel. What is my answer? 1 over minutes. What did I want to solve for? Minutes. Did my conversion work?
No.
No. Ah, crap.
Flip it backwards.
Okay? One option is to say, whoops, I just solved for the inverse, so I'm just going to flip the inverse. Okay? And as long as I do that inverse to both the unit and the numerical value associated with it, I'll get the correct answer. Okay? Some people have a hard time. It's not sort of, it absolutely is true. Okay? Let's say you go through, you've tracked the units, and you say, well, that's not what I want. That whole inverse thing, God, Mike, shut up. I don't understand inverses. Fair enough. Let's fix this. Okay? Because this we would need to invert. Okay? It's not fun to invert, so let's not do it. Let's go back and say, let's solve this appropriately. Okay? I want minutes. Minutes is a measure of time, which means when I go back to the given information, I need to find my unit of time and I need to place it on top in the numerator. The unit of time I'm given is hours. Okay? But I'm not given just hours, I'm given kilometers per hour, so the unit kilometers is now on the bottom. What is the conversion factor between kilometers and hours? 1 hour is 105 kilometers. Which unit do you want to convert, hours or kilometers? You have to do both. Pick one. Kilometers. What am I going to convert kilometers into?
Miles.
Why did I pick miles and not meters, or feet, or inches, or centimeters?
Because we have the conversion.
I'm given the conversion factor, and if I look at my given information, miles is a unit I'm given. That's why miles makes sense. I can go to any other unit, that's fine. But what I'm trying to do is aim for something that's close to what I've got. Kilometers per mile, I already forgot the number. Oh, it's written right above. 1.61 kilometers is 1 mile. Yeah? What happens? Kilometers cancel, and we'd have hours per mile. What unit do I want to take care of now? The hours or miles? Okay. Because I actually want to get to Paul's question at the later stage, I'm going to listen to Melissa here. We're going to make the hours into minutes. How do I make hours into minutes?
12 seconds.
Hours needs to go into the denominator so that it cancels. Do I know a conversion factor between minutes and hours? 60 minutes is 1 hour. Yes, you should have that memorized. If for some reason on a test you're like, oh my God, I don't remember, raise your hand and ask. And I might be like, you should really know that. I might even say you should look at a clock, and then I might walk away and be like, that's a jerk move, it's 60. 60 minutes is 1 hour. Okay? So, I now have minutes per mile. And here's where we're going to get into Paul's question. So Paul, you said up here you didn't like this. Arbitrary. I'm saying that there's no unit associated with that one.
Agreed.
Let's move through into this next calculation. What am I going to do?
Cancel out miles.
I need to cancel out miles. Am I given miles?
Yeah.
What am I given of miles?
90.
You've got 1.
What am I given? This goes back to the question. I'm given 90. Well, that's an eraser. Let's try that again. 90 miles. Over what?
No, nothing.
1. I can't leave it blank. Where is this 1 coming from up here? The exact same place it's coming from down here. And now you're saying 1 what? 1 what? I wonder why 1 what? 90 miles is equivalent to, sorry, a stupid thing there. 90 miles over 1. Because if I divide 90 by 1, what do I get? 90. If I divide miles by 1, what do I get? Miles. I'm not changing the meaning of the given information, 90 miles. All I'm doing is adding a numerical factor, a placeholder, if you will, to keep the 90 miles in the numerator. In the previous calculation, what is that 1 serving to do? A placeholder to keep the 90 miles, the given information, in the denominator. there isn't a unit associated with that 1. It is there as a placeholder to tell you where to put your calculation. Okay? The instant you make it a numerical value, it's not 90 miles anymore. You've changed the meaning. If you make it a new unit, you've changed the meaning. It's no longer 90 miles. Okay? So all we're doing is introducing something as a placeholder to make sure that that value goes into the correct numerator denominator.
Super convenient placeholder.
It is. Because if we don't do that, what do we have to do? Memorize a formula to go through and solve every single question. Okay? Which, admittedly, you've done for these units. You have because of your helicopter training. Okay? The rest of the world that doesn't deal with speed and distance and time and gas calculations, can I make it back home? Okay? Aren't worried about those conversions and so haven't internalized them as much. Okay? So this is admittedly going to be a much more difficult question for you because you are now taking your internalized things and saying, but I've internalized it. This is how it works. I know it works this way because it worked. I made it home. Okay? What I want you to do is stop internalizing. Okay? And that's where this section becomes challenging. For me, remember, the meaning behind all of these conversions, this particular chapter, was not to say, do it my way. The meaning behind this is, here's a way to do it that is not internal. It is an external method. Use your internal method. Prove my external method works. Once you've proven it works, now what can you do? Now we can move into the next unit on moles, where you don't have an internal method. You have an external method that allows you to go through and do those same calculations so that you can start to get numerical values, so you can start to come up with the relationships, so you can start to understand the meaning of moles. Okay? And that part takes a lot of time.
Let's keep finishing. Finish that.
Okay, let's finish it. Miles cancel, what do we have as a unit? Minutes. It is finished. That bottom calculation is done.
No, did not.
What?
So, I don't know, whatever the number is.
80, it's
82.8.
Yeah, we had to do 6.61 times 60 times 90. Feels like we've seen something.
So we just multiply the whole,
You
everything.
multiply everything on the top,
Over what?
not over 1. You multiply everything on the top, multiply everything on the bottom, and then divide those two things.
Oh, okay.
Because that's numerator denominator. Yeah.
You can't say that part.
Okay. So yeah, that gets back to the meaning of that format. So let's address that.
That's a big part of it.
When we say yes, when I say miles per hour, what do you need to do for a calculation? Miles divided by hours. Right? That was a unit system that you were used to seeing, used to recognizing. You didn't take the step from that internalization out to the calculation. You're right. I didn't talk about that. Your numerator over your denominator is a division. Denominator is the same thing as saying your numerator divided by your denominator. And you should get that answer. You don't? Okay. Right. So your calculator spits out 82.8. There was then a question. Sig figs. And it becomes 83. We only have 2 sig figs, and I believe it's because of the 90 miles. I think there was a decimal point there. So you get the 2 sig figs. That's larger than 5, so we add 1, and your answer becomes 83 minutes. If there's a decimal point, no. Hi? It's the method. Okay? I can't stress enough. It's setting up this, and they get different names. Dimensional analysis, ratios, train tracks, right? Railroad ties. I don't care what you call it, you're doing the same thing. You're looking at those relationships and how do you change those units. The ideal or the system behind this is that we can string together multiple conversions. We have 3 conversions strung together in one big calculation, okay, without having to do multiple separate ones. Okay? A lot of that is set up for us. That makes life a little bit easier. Questions? Okay. You don't have to like it. You will probably have to use it. Okay? So every time you look at between those X's, between our crosshairs, it's not really crosshairs, but close enough, between the X's, those have to be established relationships or established values. Don't start adding extra conversions into it. Again, you could do it right. The odds are you'll do it wrong, and the odds are you'll do it wrong on the test because we've already established we're already freaked out on the test. So you're probably going to make the mistake then. Okay? I want practice on this. I want the work to be shown. Which brings up another big point. I've been altogether too lazy about grading homework. And what I've accepted within your homework is not showing work. The answer is A to question 1. The answer is B to question 3. No, it's not happening anymore.
Like in our problem solves?
And your problem solves. Yep. And the problem solves specifically. That's the only place where I actually look at work.
That's what I was
Okay? You need to be showing work. Well, the answer is just B. No, it's not just B. There's a meaning assigned behind B. How did you get to that answer? It could just be, well, that's the symbol for copper, you idiot. That's fine. That's work. Write it down. I'm okay with that. But you're at least acknowledging it. The next part that I want to address when it comes to the homework. Okay? What I'm seeing a lot of people doing, and it's not everybody, so I'm not trying to single people out either direction, okay, is you're picking homework questions that you know how to do. You knew how to do it. Don't do that question. That's a dumb question to spend time on. What you should be doing is spending your time on the ones that you don't know how to do, the ones that you are going to fail at doing. Because if you don't do it in the homework, guess when you will get that practice?
Test.
On the test when it's not practice anymore, and that's going to really hurt. Okay? I'm not looking at the homework to see that you get right answers. I'm looking at the homework to see that you're working. Show work. Okay? So, there's our textbook method on moving through. There's a variety of different phases to this. Okay? I'm glad I just deleted everything. What a jack. So, our textbook goes through and says left and right. A few people that have been working with me in the tutoring center, I've started, instead of going left to right, is actually right all the way to left. What do I mean by that? I want minutes. Minutes is a measure of time. Time is located in which place? The top or the numerator, which means I'm going to go back to my given information. I'm not given minutes, but I am given a unit of time. I want that time to show up in the numerator. It's changing the order in which you do the calculation. Some people see this easier because you can start at the extreme right and just work your way to the left, as opposed to guessing how many conversions you need in between. Okay? I will admit, I will probably start trying to do this. I've never done it that way in my life, but it just seems to start making sense to me. Okay? Yes?
So I know that this is probably really silly, but these conversions are the ones that I have the most trouble with. So with like the last question that we just did with converting time and stuff, if we're looking for time, time is always going to be the numerator, right?
So let's be careful on that. If I'm looking for time, like a minutes and hours, then time will be in the numerator. That's because I'm looking for time. What if I'm looking for frequency? Well, then frequency is in the numerator. What are the units on frequency? Hertz, also known as cycles per second. Where is time? Okay. time is in the denominator when I'm solving for frequency. So when we're saying time is always going to be in a location, really don't like saying that statement. Write out what you're solving for. Write the unit, tie it back to whatever that measurement may be. If your unit has that measurement in the numerator, then yes, it needs to be in the numerator. Because, well, it's in the numerator. If we did something like frequency, we're writing out or rewriting our unit time is in the denominator. Whenever I use my conversions, time had better show up in the denominator. So yes, wherever the unit measurement shows up in your answer, it will show up in that same place in your work. Okay? Anybody else equally stressed out? Yay, okay. How come I got more hands on stressed out than lazy? Really?
Because we're lazy.
College.
Okay. Fractional notations. Okay. English. There are 10 to the minus 2 meters in 1 centimeter.
True.
True. Okay. Is this statement equally valid?
Yes. Got a 10 to minus 2 centimeters in 1 meter.
Let's solve it out.
Plus
This is saying 10 to the minus 2 centimeters equals 1 meter. Right?
But that's false.
Let's get that 10 over with our other unit, just like we had in the top one, right? Let's divide everything by 10 to the minus 2. I get 1 centimeter equals 1 over 10 to the minus 2 meters, which is the same thing as 10 to the second meters. 1 centimeter is 100 meters. Whoa. But I'm still using 1 and 10 to the minus 2. Why is it changing its meaning? Because you changed where the unit was referencing the number. The unit drives your answer. Just because you see the same numbers does not make the statement valid. Okay? Track where your units are. There is an English to mathematics to then solving. You have to make that leap. Okay? Compound units. We just did this with that speed one, so I don't think there's a whole lot to talk about on this. Our compound units just have more complex pieces behind them. You may be required to do multiple compound unit conversions. Okay? Like, for instance, dealing with length and volume. I don't remember, did anybody laugh at that image before? Yeah, a couple people laughed at that image. Okay, only a couple people. Okay? I would hope that it was those couple people that remembered when they saw a length measurement of volume that they have to be very careful because it's a trap. And we have to make sure that we do our cubing on our distances. Okay? 1 inch is not 2.5, or 1 inch cubed is not 2.54 centimeters cubed. Okay? The meaning changes with the unit. Track your units. Where is this one particularly relevant? Short answer C. Goes exactly into the same issue. Okay? Looking at that metric conversion. Okay? What's our setup on that one? Actually, I'll just cheat. I got it up here. Yeah, so for those of you that didn't show up that are watching at home, thanks for not showing up, because now Mike has a key that we can look at. Okay? What do we want for an answer? Pounds per inches cubed. When do we want it? Thank you, Sean, for acknowledging that. 220, well, let's not write that yet. I'm given 224.50, there's a point there, grams. and a volume of 10.0 centimeters cubed. Grams is a measurement of, I don't like weight, but that's the right idea, mass. Centimeters cubed is a measurement of volume. The unit I want for an answer, I have pounds, which is a measurement of pounds, is mass, inches cubed, volume. What does that mean I should do? I should probably take my mass unit and put it on the top. And I should take my volume unit and put it on the bottom. Okay? Notice again, I'm not putting them in the same thing. Mathematically, that makes sense, but I'm trying to maintain the meaning. The information given was not 224.50 grams per 10 centimeters cubed. It was 224.50 grams and a volume of 10.0 centimeters cubed. Very subtle difference, but we're trying to maintain the meaning when we go into our conversion. What units would we have at the end of that calculation? Grams over centimeter cubed. Are either of those units correct? Fix them. What do you want to fix first? Grams to pound. Most people went through and did that one. Where do I want the grams to show up in my conversion? On the bottom so that it cancels the top. What unit do I want on top? Pounds. What the hell? I have no idea how to calculate between grams and pounds. Oh, front of the exam. Yes, the front of the exam tells me 1 pound is 454 grams. Yeah, who knew? I didn't until I wrote the exam.
Is that exact?
No. Okay. So we now have pounds. Pounds. We have our mass in the correct location. Do we have our volume correct?
No.
No. So, fix it. Centimeters needs to go on top, and inches needs to go on the bottom. 1 inch, 2.54 centimeters, because you went in and did the numbers right away, as opposed to pausing and saying, actually, no, I got to deal with the units. Those units aren't quite right. I actually need centimeters cubed to inches cubed. What is my conversion between centimeters and inches? 2.54 centimeters is 1 inch. Now the cube translates into that 2.54. The work is valid, and a couple people did this. The work is now spot on perfect, but you entered into the calculator 2.54 divided by 454 divided by 10 times 224.5. Meaning you did not do what your work showed. You didn't cube the 2.54, and you got one of the wrong answers. Sorry. But your work was right, so you got 6 points out of 7. Okay? So reverse sorry, because you did all that work and you still got the wrong answer, but I gave you more points.
What's the right answer?
Do the math. I believe it's A. Okay. Are there any hints at looking at the multiple choice where you could be like, maybe I want to look at A as a potential answer?
Kind of.
What's that kind of?
D and E are impossible. Just
So
looking at,
we could go through and say
just
D and
looking
E
at pounds versus grams, D and E are impossible.
are too high. I think that's going to be a stretch because you're doing a bunch of conversions in there and those could scale it the other direction. So I personally wouldn't make that statement. Okay? It's hard for me to say you're wrong because, well, shit, you're right. So, what were you saying, Sean?
I crossed off C because it had too many significant figures.
C has way too many significant figures. All of those answers are reporting to 3 except C has 5.
So the only viable options are A and B.
But C showed up. C and A are the same numerical answer, different only by sig figs.
And then
Guess what the question was also asking about? Sig figs. You could guess A is the valid answer.
Well, it says on the front, you have to guess A is probably the way to go.
And it wasn't perfect, but yes. Yep. So there are two ways that you could have come to that answer. Yep. Okay? So, track your units, recognize your measurements, move through them. Make sense? Okay. More on density. Ignore that. Ionic charges. Isoelectronic meant equal electrons.
Yes.
Okay. I thought everybody really got this in class.
I thought I did too.
I really did. And I was pretty severely disappointed. I was disappointed right away, and then I got really excited because I was like, oh, I made a typo on the key. Usually when I make a typo on the key, everybody gets more points, and I'm like, great, fantastic. So I made the typo change, went through and started regrading, and what happened? People lost more points. They were like, no, that was the complete opposite direction the typo was supposed to go. Isoelectronics, same electrons. Neon has how many electrons?
8.
I don't accept 8. Neon has how many electrons?
Neon has fundamental.
It has 10 electrons. It has 8 valence. Okay? Isoelectronic means same electrons. Not same valence, same electrons. Though arguably you get the same answer. This would be multiple choice number 1, so I need the rest of those. Oxide ion. Well, that was a twit thing to do, wasn't it? Oxide ion. What do I need to know to be able to answer this? The formula for oxide ion. Oxide, that D is an immediate tip that I'm looking at. A single atom, so I'm looking at oxygen. Okay. Oxide ion, I wonder what its charge is. You were required to know that it's -2. Oxygen has how many electrons? 8 electrons. To become a -2, what had to happen? It had to gain 2, which means how many electrons would it have?
10.
10 electrons. That seems awful similar to neon. What was the next one?
Magnesium ion.
Magnesium ion. Did I actually draw it as a symbol this time? No.
Still magnesium.
Irritating again, right? Magnesium ion. What's the symbol for magnesium?
Mg.
Mg. Ion. Oh, it's an ion. It's charged. I have to know the charge on magnesium ion.
It's like +1.
It's a +2. I'm required to remember that. It's in the second column.
No.
Magnesium has how many electrons? 12 electrons. To become a +2, what had to happen?
That's lose.
It had to lose 2 electrons, and it becomes
10.
10 electrons.
Oh, that's looking odd.
What was the last one? Fluoride ion. Fluorine, I'm not going to write it up there because I'm out of space. Fluoride has fluoride ion, so it's F. That D is a tip-off. You're looking at an atom. So element F has how many electrons? 9. To be an ion, what charge does fluoride become? -1. It had to gain an electron. It would have 10 electrons. A, B, and C are all valid, which means
The answer is D.
the answer is D, all of the above. Okay? This is one of those questions that I saw a lot of people just say, oh, the answer is D, or the answer is C. That didn't require any work at all, right? I didn't write anything on the board. Right? Write the work down. Evidence for chemical reactions. Okay? You're supposed to know this. Okay? Those are the big things that allow you to decide if a chemical reaction has occurred. Yes, there was a multiple choice question that asked this at a slightly higher level. Okay? But you could reason through it with the multiple choice answers. It was, again, one of the most common ones missed. Okay? Evidence for a chemical reaction, if you're looking at a reaction, can you see the energy change? No, you have to measure that. Can you see a permanent color change if you're looking at an equation? That's how I say it. No, you can't see that. You have to look at the reaction itself. So the only one that I could test you on would be change in phase. How do you predict phases? Activity is not phases.
Sorry, I was like,
Getting at the right idea though.
Gas, solid.
So gas, liquid, solid, how do you know what the phase is?
solubility?
Our solubility rules. Are we given solubility rules on the front of the exam?
Yes, we're gonna reverse.
Yep, for a reason. Okay? If you go through just based off of saying we need a change in phase, you can rule out every answer except one.
I don't know how to problem.
Okay? I don't remember which question it was either, but I know it's in there. 15. Yeah, pictures. Oxidation state rules. You needed to have these rules memorized to be able to answer anything about oxidation state. Okay? You had to have those nailed down. Okay? That number of element times the oxidation state, and so admittedly, again, I'm definitely sounding preachy, and there's not a lot I'm going to do about that. Okay? This is hard. This is hard material that trips up a lot of students. Oxidations and faculty. A lot of students get confused between oxidation state and charge. They're related, but they're not the same thing. Okay? So being able to parse them out away from each other to be able to answer a question about reduction and oxidation, okay, versus balancing charges in, say, nomenclature or equations is challenging. Okay? And a lot of it comes down to that equation. The element, number of the element times the oxidation state plus the number of the next element times the oxidation state. That will always equal your overall charge. That equation is always true. That equation is super important too, because that equation is effectively what you use when you do nomenclature. Okay? In the textbook, oh, you just crossover rule for nomenclature. So here, let me give you a shortcut that removes your understanding so that when we get to oxidation and reduction, you can't understand crap. This is why that equation is in the nomenclature video, because it allows you to manipulate more advanced material. That's why it's there. That's why it should be used. Okay? Is it more work? Absolutely. Okay? What grade do you want? If you want a C, maybe I'm missing that. I usually think people want A's. If all you want is a C, then yes, fine, do whatever you want. Okay? If you want that higher grade, that higher level understanding, you have to push to those harder levels. A's require more work. Okay? Balancing redox half reactions. You split them up, and then you make sure that we don't have this issue. Once we have electrons left over, we're not allowed to have electrons left over. Okay? So when we split them, we have to make sure that the electrons cancel. Okay? Again, a challenging question. That's where we'd multiply one of those by 2. Technically, we're also multiplying the other one. What are we multiplying the other one by?
1.
What was that in the middle of the yawn?
1.
1. Okay? So we're taking the lowest common multiple between the coefficient of our electrons in both cases and multiplying opposites. It works. Okay? It works every single time. It's lovely. It's beautiful. It's pretty. Is it painful? Yeah. But it works. Okay? So this is where we had that question. Okay, we had a quiz on this. All right? I just graded those quizzes, by the way. You all did quite well. Some people got them wrong, but the majority of the class got this question right. And yet, on the exam, the majority of the class got the question wrong. You didn't ask this question. I was kind of sneaky and backhanded about it, but yes, I did. What is the charge on a sulfate ion? -2. So that if I said, I don't know, partnered copper with sulfate, it would become that formula. Does that change the charge on, or the oxidation state, sorry, on the copper? Nope, it stays the same. That really has no effect on the copper as our product. Aluminum with sulfate to balance. Yeah. And the question asked, how many electrons were transferred? Did I change the meaning of the question? Nope. I just buried it a little bit. Buried it a little bit inside the nomenclature rules and understanding how to balance out charges. Okay? The exact same question was on the test. Okay. After that, temperature conversions. I do take responsibility for this one because I think what happened here, sorry dude. I think what happened here is we talked about the temperature conversions and there weren't any on the practice exam. It was covered in the class and we just quickly forgot. That is actually why I tried to pick the easiest conversion on dealing with Celsius and Kelvin. Okay.
Which you should memorize.
Which you should memorize. Okay. After that, oh my God, chapter 8 and chapter 9, that's what was on the test? No, that's the new slide. Okay. So, if you go through and look at the uploaded slides, there's a lot more information in there. There's about 20 slides. We covered 15, 18. I deleted some slides. Because I didn't think they were important. Okay. All of these slides are particularly relevant for Wednesday.